Hi everyone, Professor Christina Sover here from Cal State Long Beach speaking, and in this video we're going to start with a speed time graph and create a story dialogue that goes along with it. So again, this is from activity 8 in chapter 14 in our textbook. You want to write a story that could be represented by the graph below. In your story, identify the quantitative relationship being graphed. We're trying to graph the relationship of speed over time. Recall that speed over time is a speed time graph. This is important to note because some students might automatically jump and say, oh, this must be distance time graph. And from A to B, you went away from your house. B to C, you went back to your house. C to D, you stayed at home. D to E, you left home again. E to F, you stayed away from home again. If this were a speed time graph, that story would be valid. However, this is not a distance time graph. It's a speed time graph. Again, this is a speed time graph. So we're not talking about going away or towards something. Between letters here, we are just quantifying how fast or slow or still we're staying. Now, these letters are actually associated to points in time. So we have time A at the origin, time B, time C, time D, time E, and time F. If you recall from the previous video, in speed time graphs, horizontal lines represent constant speed. So this E to F is some constant speed. So we're maintaining that steady constant pace. Another spot for constant speed is from C to D, but moreover than it just being a constant speed, C to D is on the time horizontal axis. So this is actually no speed from C to Z, it's zero speed. You're staying still. You're not moving at all. What we haven't seen yet is what happens in a speed time graph when the lines are angled. They're not just horizontal. So I'm going to color coordinate those. We have A to B we want to talk about. We have B to C we want to talk about. And we have D to E we want to talk about. What do I notice? The pink and green graphs are both positive slopes. So I'm going to write some similarities over here. The pink and green portions of the graphs are positive slopes. All right. What else do I notice? Well, the orange portion of the graph is a negative slope. Orange portion of the graph is a negative slope. Okay. Now, what else do I see? I can easily see that the pink A to B portion of the graph is more steep than the D to E portion of the graph. So I'm going a higher number from A to B than I am from D to E. So this needs to be a bigger number. This one needs to be a small number. Again, numbers don't matter here for these portions, but just in my head, I'm thinking the green needs to be a smaller positive number than the pink. But looking at it even farther, the orange graph needs to be even bigger than the pink one because it's more steep. So I'm going to put even bigger number. Now, language is funny here. I don't mean an even number like 2, 4, 6, 8. I just mean a larger number than the pink value. So now we want to think about a story here. Well, I know from E to F, I maintained a constant speed. So I'm just going to write that down. I maintained a constant speed from E to F. Okay, that part's good. Now from C to D. I didn't move at all from C to D. I did not move at all from C to D. Now we're talking about speed here. I have a positive slope or I have a negative slope going on remaining. For the space from D to E, which I'm going to have to put, I'll put a star here and write it down here, the star. I increased at a regular pace from C to D. I increased my speed at a regular pace from D to E. If I increase my speed at a regular pace from D to E, then for the pink portion, I increased my pace, or my speed, I should say, at a faster regular pace from A to B. Now, the way I'm going to word the orange portion, which let me put a box around the star so it looks separate from everything else. Let's put a big old dot for the orange and we'll write it down here. Now, I didn't increase my speed here because it's negative. We're going to say I decreased. I decreased my speed at, well, we said even bigger number. So an even faster regular pace from B to C at an even faster regular pace from B to C. Whew. Okay, let me erase some stuff so we can try to reorganize our thoughts here. We know it's a speed time graph. We don't need that anymore. We've already talked about pink and green being positive slopes. We took care of that information. And we know the orange graph is going to be a negative slope. And we already took care of that by saying decreasing. Now I'm going to use a different color here. I'm going to use black to write our story in order. So to start off, I increased my speed at a regular pace going from point A to point B. Then I needed to decrease my speed much faster than previously, going from point B to point C. Well, when we look at the next spot from C to D, I didn't move at all. So from point C to D, I stayed still. From point D to E, I increased my speed slightly. Might be a nice word to use here. Before maintaining the same, let me fix that, the same, same speed from E to F. All right, that's my story I'm going to go with without context. So to start off, and I'll highlight this in red. To start off, I increase my speed at regular pace going from A to B. Then I need to decrease my speed at a much faster rate, getting from C to D. Then I stayed still from times C to D, increase slightly from D to E, and maintain the same speed from E to F. For me, I think about this in a car, and this could be that I was going really fast on the freeway because nobody else was there, and I was trying to get to my destination a little bit faster. I was jamming out, listening to music or what have you. Then I saw a car at point B. It's like a car, and that car was a cop car. And I was like, oh no, I don't want a ticket. So I have to slow down really fast before they notice me going really fast. And then I slowed down so fast, I decelerated entirely. My car just stopped. I stopped decelerating. Then from D to E, I increased a little bit to make sure I was looking normal. And then I stayed at that same safe, cop's not going to give me a ticket pace from E to F. Notice I said a word decelerated because speed over time is acceleration. So the relationship that we're graphing here is acceleration. That's why it makes sense to decrease fast. Acceleration can decrease fast. That part isn't as important for our class, but being able to create a story based on a graph or even create the distance time graph from this picture could be pretty important to do. And in this case, you'd just be going farther and farther away from your initial point. There was no indication of going backward because you're progressing during time. Just because you are going negative from B to C, you're decelerating, that doesn't mean you're going backwards. It just means you're slowing down. You're still going forward, just slower than before. Thank you so much for watching. If there's any questions, please feel free to email me or reach out to me as soon as you have any questions or want me to be an option for you. And I'll get back to you as soon as I can. Thanks so much again. Have a great rest of your day. See you in class. Bye.